So this is my friend's first time dealing with derivatives and dealing with integrals, but we're looking at derivatives here. So this is the first problem. We have f of x is equal to ln 4x squared minus x plus 5. We have this rule right here. Why don't you explain the rule?
So basically, ln of n is equal to 1 over n, and n stands for number, and then the derivative of n. So you multiply it by the derivative. So what we did here was we did 1 over the 4x squared minus x plus 5, and then we also multiply it by the derivative of 4x squared minus x plus 5.
And that's like representative of the n, right?
Yes.
So everything in here.
So yes, this is all n, and this is all n.
All right.
And then here at the bottom, so we keep the first part of the equation the same, 1 over 4x squared minus x plus 5.
Because the formula says we don't derive it, right?
Yeah, we don't derive it at all.
Okay, but the next part.
But the next part we do derive, which 4 times 2 is 8, and then 2 minus 1 is x, and then negative x normally has a 1 on top, and the 1 hops down is multiplied by x, which is 1. X disappears because x to the 0 power is 0, and any whole number that's within an equation when it's being derived is equal to 0.
Right, so any constant is equal to 0. And then we get our answer. So this is the answer for number 1, right?
Yes.
Okay, cool. So now we have a log-based problem. We had ln up here, and now we have log. So if you want, you can explain the similarities.
So log and ln both, you have to find the derivative of it, and you start with the equation of it, and then you find the derivative of it, and the number base turns into the actual number that would be on here on the top, and down here, so it's about the same. Down here you actually find ln of n. So the two equations kind of connect with each other.
The only difference is that with log base, you have a base. It's very similar to this ln. You're kind of making the log base look like an ln. So here you can see the log base is, we have more, so we're going to have more to do. Right here we just have ln, so we just go n prime. Now with a log, we're going to do ln. So up here we just had n, down here we have 1 over our ln. And then we have to take care of our base. So it's 1n ln of our base. So whatever the base is, it's just going to be ln of that base. That's set. That's going to be there for the entire problem. We're not doing anything with it. And then just like as this previous one, we took n prime, we're going to take ln prime when we have the log. And then n is just whatever number we have in here. So you can go and explain the problem now.
So first we start with the base. So it turns into ln of 8 because 8 is the base. And then you multiply it here by ln of x to the third plus x to the second and derive it because that is our number portion. The 1 ln over 8 stays the same, it stays constant. And so here we're finding the derivative. Now because this here looks pretty similar, this is this. So now I separated here the equation. So 1 over x to the third plus x to the second, because you don't find the derivative of this because it stays as a fraction up here. And then here you have 3x squared plus 2x because 3 comes down, 3x, 3 minus 1 is 2, and then 2 comes down, and then x to the first power is just x. And then you multiply the two together, and this becomes the numerator, denominator stays the same, ln stays exactly the same, and then you combine the two.
Cool. So we've done an ln, we've done a log base, and now we know that they're similar, different, but they're really easy. Once you know one, you can kind of see the other. It's just a little bit more work with the log base.